Negative 1 minus 2 is negative 2 dx. So negative x to the third over 3 plus 3x squared over 2 and minus 2x. From 1 to 2. So now when I plug in 2 and subtract when I plug in 1. I cannot simplify anything, I was just looking. So this is negative 8/3 plus 4 over 2 is 2, 2 times 3 is 6, and minus 4, minus, I'll put in parentheses not to forget to distribute negative 1. So, negative 1/3 plus 3/2 minus 2. The number cannot be negative. It's an area enclosed between two graphs. So make sure that you do not get a negative number. Okay, negative 8/3. And then this is plus 2, and this is, plus 1/3 minus 3/2, and then plus 2. So negative 8/3 plus 1/3 is negative 7/3. 2 plus 2 is positive 4, and plus 1/3. Okay. Sorry, minus 3/2. Minus 3/2. So negative 8/3 plus 1/3, negative 7/3, 2 plus 2, and then I have to copy what I left untouched yet. Minus 3/2. Okay, the least common denominator is 6. So this one needs a 2, this one needs a 6, and this one needs a 3. Negative 14 plus 24 and minus 9. For negative 14 minus 9 is negative 23. 24 minus 23 is 1, 1/6. We expected it to be tiny. So this area. So now the graph, the correct graph, because I stretched it over there, should be something like this. And somehow kind of difficult to show. Something like this. And the area is right here between x equals 1 and x equals 2. We did not determine the y values. We can. So when x is 1, 6x minus 1 will be 5. And when x is 2, 12 minus 1, 13. So this point is 1 comma 5, and this point is 2 comma 13. So we do have to find the graph, or we have to graph the functions and see the intersection. That is part of the solution. I can't just say, oh, I think it looks like that. No, I have to graph them. Good. Let's see what other topics. We did look at consumer surplus and producer surplus. Do we want to go back to functions of several variables? Do we want to look at differential equations?
Yeah, can we do those?
Yes.
So 5.7, right?
Yes, 5.7. Okay, so on page 522, I see some problems there. This page 522. Let's start with 29. We can look at a few examples here. So we have dy over dx, which is 8x to the 7th times y. So when we solve a differential equation like this one, what do we have to do first? What is our first concern?
Separating.
Yes, awesome, yes. So what you can do first is just cross multiply, and you get 8x to the 7th y dx. You will keep these here because they are all with x and the constant can stay, but this has to go. The only way I can make it go is to divide both sides by y. So then I have dy over y equals 8x to the 7th dx. And now, only now, we will integrate. What is the left-hand side equal to? When we integrate 1 over y.
The natural log of the absolute value.
Excellent, excellent. And this is easy, right? It's 8x to the 8th over 8 plus a constant c. Nice. So, great job, Amanda. Thank you. So then, I think I am on page 7, yes. So next, I will write natural log of the absolute value of y equals x to the 8th plus c. And remember, this is a log equation, and the base of natural log we know is e. So then the absolute value of y will be e to this number. So e to x to the 8th plus c. Now remember what we do next here. We rewrite it as e to x to the 8th and multiplied by e to c, which changes into a simple constant c. From here, I should write y equals plus or minus as e to x to the 8th times the constant c. But we can also include the plus or minus in the constant. So the general form will be this, e to x to the 8th. Okay, let's also look at any questions on this problem. Okay, so let's look also, or you can choose more, of course. So dv over dt equals 2v to negative 3. Again, first cross multiply. dv equals 2v to negative 3 dt. You can write it as dv equals 2 over v to the 3rd dt, if that's better. And obviously now I will multiply both sides by v to the 3rd power, because I want v on one side and t on the other. So then I have v to the 3rd dv equals 2 dt, and this is what I integrate. So can anyone give us the left-hand side or the right-hand side? Any of these two? Very good. Don't forget the constant. Yes, because no, because it's an indefinite integral. Good, awesome. So therefore, I multiply both sides by 4. V to the 4th equals 8t plus 4c. So then v will be basically the 4th root of 8t plus 4c. And yes, it has to have plus or minus in front. You do not have to write 4c. You can again consider it as just c. This is fine. This is fine. Let's also look at 34. Where we have y prime equals 4y plus xy. So what do I do next? if I'm given something like this and I'm asked to solve? What is the first thought that comes to mind?
Rewrite y prime.
Exactly. Awesome. Indeed, I have to write this. This is not a good notation. I cannot have the dy and the dx, right? So I need this first. Awesome. And then I see that this common factor will be y, and I will write it correctly as x plus 4 in parentheses. Now, if you want, you can cross multiply first, as dy equals y, x plus 4 dx. But this and this should stay on one side, but this should be on this side. How do I make this go to this side? What should I do to both sides to make that happen? Very good, of course. So then I have dy over y equals x plus 4 dx. They're completely separate. X is alone on one side, y is alone on the other. So then I can integrate. And when I integrate, the left-hand side, as you already told me, is the absolute value of y, and the right-hand side is x squared over 2 plus 4x, of course, plus a constant c, because this is an indefinite integral, of course. What do we do next? So we have to solve like we did before a few minutes ago. So that's on page 9. So then I have e to all this is the absolute value of y. E to all that. So x squared over 2 plus 4x plus a constant c. But I will rewrite it as like we did a few minutes ago as e to x squared over 2 plus 4x and multiplied by e to c, which will change into simple c. Can you keep it? Yes, I'm fine with that too. Okay, so then I have y equals plus or minus this constant and this, e to x squared over 2 plus 4x. And yes, you can consider that this is another constant c. You can keep it as is, you can keep it with e to c, I'm fine. But this is the way we write it. Okay, let's go back to chapter 6. Partial derivatives, d-test, least squares for exponentials and linear.